Okay. So in the last lecture we have discussed. वापस आ जाओ सब लोग अभी पप्पा का स्थापना से, राइट? आ गए क्या वापस?
हाँ सर.
हाँ, वापस आ गए ना सब लोग? गणपती बाप्पाला त्याच्या जागेवर सोडा, त्यांच्या जागेवर सोडा आणि तुमच्या जागेवर तुम्हाला या आता वापस. Okay. In the last lecture, we have discussed about different windows, like types I told you already. And we have discussed the steps to follow, like how FR filter can be designed with the help of the windows. Okay. I have given you the list also. So what are the different types of windows? What are the different types of windows?
Rectangular window, Hamming window,
Okay.
Hanning window,
Like, okay. What else again? Triangular window. Okay.
Blackmon.
Okay. What else again?
Kaiser.
केजर विंडो. ठीक है. सो ये अपने डिफरेंट टाइप्स ऑफ विंडोज है. अभी यहाँ पे while designing an filter using a window, so which step is going to change? कौन सा स्टेप चेंज हो रहा है आपका? कोई बताएंगे? So steps I have given you. So in normal FR filter design, what we are doing, first we are noting the value of desired frequency response, then we are calculating the impulse response or a filter coefficient we are calling. Then after that क्या कर रहे? Truncating of the given sequence. तो जब truncating कर रहे वहां पे, what we are writing is h of n equals to hd of n for the value magnitude n less than or equals to n minus 1 by 2. So ये step आपका change होगा, बाकी सब सेम रहेगा. तो in windows what will happen is that h of n is equals to hd of n multiplied with the window function omega of n. Rest all thing will remain same. Okay, so let us see the different windows. So for today's, you just write a title as rectangular window. So this is what a definition of rectangular window. Are you able to see the screen?
Yes, sir.
Yes, sir.
Now, this is what a definition of rectangular window. What I am writing is omega r. Here, omega of n representing as a window notation. R stands for rectangular. So omega r of n equals to 1 for minus of n minus 1 by 2 less than or equals to n less than or equals to n minus 1 by 2 and is 0 otherwise. So this definition already we have seen. For example, आपका अगर n value 25 है यहाँ पे, तो सिग्नल कैसा रिप्रेजेंट होगा आपका? If n is 25, then where the value of this omega of n is present?
-12 to +12.
-12 to +12. एम्पलीट्यूड क्या रहेगा उसका? What is the amplitude?
1.
1. And whether it is continuous or discrete? Whether it is continuous or discrete?
Continuous.
Very good. Thank you, madam. कौन बोल रहे अभी? खोबरे?
हाँ सर.
कसं हो madam? How it is continuous? As I have represented it is omega r of n. N stands for discrete time function or continuous time function?
Sorry, sir. Discrete, sir.
काय हो मॅडम, असं एवढे छोटे छोटे गोष्टी कन्फ्युज करून घ्यायला लागलाय, राईट? Here n is there, as n is there, it's like a discrete function. So it looks like this way. तो सिग्नल आपका कैसा दिखेगा अभी, ये. Getting my point? Note down this. First you write down the definition. Note down the rectangular window graph. Any question here? Hope you all able to see my screen. Screen दिसतोय ना properly सगळ्यांना?
हो सर.
Yes, sir.
Okay. Please note down that. First note down the definition. Then note down the graph. Or
Yes sir.
now, this is what a definition of rectangular window and its graphical representation. Hope everyone has understood. यहाँ पे कोई confusion? Any confusion here?
No, sir.
No, sir.
Maybe you may expect define the different types of windows. तो वहां पे आपको definition लिखना है and then you need to write its graphical representation और उसका spectrum का एक formula है. So this you just write down. The spectrum of the rectangular window is given by the spectrum of, so this is a time domain function and this is again spectrum, we are writing it in the frequency domain part. Spectrum of the rectangular window is given by omega r of e power j omega equals to n equals to minus of n minus 1 by 2 to n minus 1 by 2 e power minus j omega n. So these three formulas you need to remember. It is like a formula of our Fourier transform. क्या रहता है यहाँ पे? Suppose यहाँ पे omega of n लिखा मैंने, right? It is like multiplication of omega of n into e power minus j omega n. लेकिन ये लिमिट के लिए omega of n का वैल्यू 1 है, तो उसके लिए यहाँ पे लिखे नहीं है उसको. ठीक है? Understood? Or
Yes sir.
okay, now suppose if I want to plot its frequency response and magnitude response, so let us see how it looks like. तो ये frequency response plot कर रहे हैं हम, जैसे कि मैंने अभी आपको first day we have discussed, right? If I am plotting its frequency response, so it will be like looking like this, and then if I am plotting its magnitude response, so it will be looking like this. So what it is indicating here? So if I have like n equals to 25, then its frequency response will look like this, and its magnitude response, जैसे कि हमने first part में design की है, like we have designed low pass filter as well as the high pass filter. So there we have calculated the frequency response as well as the magnitude response. लेकिन हमने वहां पे frequency response को plot नहीं किए थे. Only we have plotted the magnitude response. So what you are observing with this? तो इसको हम 2D plot बोल रहे हैं, right? This is what we are calling it as a 2D plot. So here, so this at 0, the first one is showing as a maximum one, and these are all the ripples which we are getting, and that is at the minus 13 dB. As a minus 13 dB, we have a ripple or attenuation in dB, we can call it is. Are you drawing this? हेलो,
Yes, sir.
ड्रॉ कर रहे क्या इसको?
हाँ, sir.
नाउ इफ यू ऑब्जर्व द डिफरेंस हियर, तो क्या समझ में आ रहा है आपको बाय लुकिंग एट दीज टू ग्राफ्स? व्हाट इज द डिफरेंस?
फ्रिक्वेन्सी जास्त आहे.
फ्रिक्वेन्सी
जास्त आहे.
नाही मॅडम, फ्रिक्वेन्सी हा ओके जास्त आहे, आणि as the value of n is increasing, so what you are observing, this width of the main lobe is getting smaller here. ठीक है, तो ये आप इसको जो हम मेन लोब बोल रहे हैं ना यहाँ पे, so if you look at into this part, so this is what the main lobe for the n equals to 25. ठीक है, तो यहाँ पे अगर आप ऑब्जर्व करेंगे, this is the main lobe for n equals to 51. तो क्या डिफरेंस आ रहा है आपका? मेन लोब का साइज कम हो रहा है, राइट? द विड्थ ऑफ द मेन लोब इज reduced as the value of n is increasing. तो क्या मतलब है उसका? विड्थ आपका मेन लोब अगर आपका कम हो रहा है, so that is indicating the transition band is reducing. ठीक है, so transition band वहां पे हो रहा है, like you are getting less means the ripples are also going to be reduced. So if you look at into this part, और यहाँ पे देखो, इसके पार्ट्स देखो, राइट? तो यहाँ पे रिपल्स कम हो रहे हैं आपके, गेटिंग? yes or no? हेलो, हेलो, am I audible?
Yes, sir.
So you understood the difference now?
हाँ सर.
तो जैसे जैसे आपका n का वैल्यू बढ़ रहा है, then the main lobe value is getting reduced, and then the ripples are also going to be reduced. That is the main difference. Okay, now take down this. प्लॉट कर सकते हैं इसको? It is just for your understanding purpose. So that is what all about the rectangular window. और हेलो,
No, sir.
हेलो, ओके, मुझे लगा सब लोग अटेंडेंस मार्क करके चले गए. So most of the people are like they are very hurried to put the attendance. Okay. Anyway, we will stop it here. So further, we will continue again. Shall I close the screen?
Okay, sir.
Okay. Thank you.